Okay, this is a video about transpose and apply method of division. This is a video number 9. Let us continue. Highlights. We'll continue to use two-step division method we developed in the previous video. We would use, in addition to the natural base numbers, we will use also use the proportional base numbers. Let's continue. This video introduces the concept of altered remainders and see where these can be used. Contents are, we would talk about what the method of transpose and apply method is. We would use that method to divide by divisor of 2 digits. We would look into an example where there are issues with excessive large numbers, also negative numbers, both in the quotient to value positions and also in the adjustments due to the transpose. We look at some of the recurring numbers we can compute using transpose and apply method of division. We would also look into some examples where we are trying to use larger divisors of 3 and 4. Let's see what the transpose and apply method is. In this method, we take advantage of a divisor being close to a base number. In the simplest terms, we divide by the base number and make adjustments for the difference. Divisor is close to base number, it's not equal to base number. Okay, let's continue here. It's an indirect method. We achieve a result by dividing by another number, which is a base number. So it's not a direct method. We do not divide directly by the divisor. Instead, we divide by a base number, sometimes proportional base numbers, and make the adjustments. Let's continue here. In this video, we will consider only divisors which are more than the base numbers. The one which are less than the base numbers were considered in. Let's look at what we need to do. Consider an example here, 1002914 divided by 11. So we're looking for a division by 11 which is a close to a base number of 10 and is more than 10. Let's continue. So chosen base is 10. We'll use a two-step for division, which is 10 times 1. First division is by a natural base number and second division is by its other factor of the base number. Let's continue here. In Nicholas method, we subtracted divisor from the base. We subtracted 11, this 11 from base number, and we need to do the same here also. So that's what we need to do. We got to subtract the divisor from the base number. Let's see what we do here. So in a Nicholas method, we will compute a deficiency, and its equivalent here would be when 11 is more than a base number, divisor is more than a base number, would be 10 minus 11, okay, which is equal to minus of 11 minus 10. This is, we just applied a transpose here, okay, and 11 minus 10 is a surplus of 11 from base 10. So this is a surplus, and we multiply the surplus by minus 1. Okay, we call that, we just did a transpose of the surplus. Surplus was plus 1. We transpose that to minus 1, and we call the transpose of the surplus. Let's continue here. So if you treat transpose of surplus, this number here, as a deficiency, just like we call deficiency equivalent in this case is, we should be able to use development of video on Nicholas method and be done. Okay, so we got a deficiency. We were using deficiency before, and not that fast. Tirthaji devoted a whole chapter. That would not be fair to Tirthaji. Okay, so we just can't quit. Let's look at the issues here. Further, the issues are different. In Nicholas method, the issues was overflow. We keep adding, and sometimes we get a multiple digits in a quotient place and also in the adjustment place. So we had a multiple digits in quotient and also adjustment positions. Okay, let's continue here. In this division, which is a transpose and apply division, this you will also be underflow, negative digits. So we'll get also negative digits. We have positive digits, negative digits, multiple positive digits, multiple negative digits. Okay, let's continue here. We mitigate the issue by using altered remainder. We'll investigate what altered remainders is, concept is, and then we would use that to mitigate some of the issues arising from negative numbers in a quotient place and also in adjustment place. Transpose and apply continue. In this video, we would use a two-step division developed earlier. So we would continue to use a two-step division. Compute recurring numbers, do some of the numbers, we can still compute some recurring numbers using transpose and apply method of division. Explore and handle the issues if they come in. If there's some issues come in, we would see how to handle those issues. And no, we don't need to show that this method emulates straight division method. We know it does. So we already showed that this this method and the previous method we discussed was Nicolet method of division. It do emulate the straight division. But now we consider example. Example is 1002914 divided by 11. Base is 10. 11 is close to a base 10, natural base number, which two-step divisions are 10 times 1. 10 is natural base number and 1 is the other factor of the chosen base. Okay, transpose of surplus is 1. Transpose surplus is minus 1. Okay, let's continue here. Notation. In this discussion, we will use the following terms: transpose, transpose surplus, negative of surplus, and equivalent deficiency in interchangeably. And I'm using the transpose most of the time. So uh, in the previous video on Nicolet method, we had deficiency, and we will be using in this video transpose. Uh, let's continue with divide by 11 example. We started in previous slide. Let's continue. So example is 1002914 divided by 11. Okay, base was 10, and two steps are 10 times 1, and transpose is negative 1. Okay, negative, it's a minus 1 here. Surplus is 1 and transpose is minus 1. Okay, let's continue. So this is the way set up the problem here. This is my dividend and that's my divisor, and this is my transpose, and base number is 10, and two steps are 10 and 1. So we would divide first by 10. Let's continue. So divide by first 10 by our first division. This is right first division here. Okay, how to do that? We just draw a line to the left of one digit. So we just got divide the dividend by 10, and left of the line is a quotient and the right is remainder. Okay, let's continue here. Now divide the leftmost digit by 1. 1 is our second division. Second division. So we got a 1 here. Now adjustments here. We are dividing by 11, not by 10. So we have to make adjustment. Adjustment is the quotient digit here 1 and the digit in the transpose. 1 times 1 is minus 1, and that's my adjustment for the next dividend digit. Number of zeros in the base is 1, and the adjustments go under one digit, next one digit of dividends. So adjustments is only to one digit. Okay, so negative 1 would be adjustment 1 time minus 1. So that's my adjustment. Now we would divide in this next column here. We have a 0 plus minus 1. So we have minus 1 here. Divide next column by 1. Okay. So that's minus 1 here. Okay. Now adjustment. Adjust for next transpose, which is negative 1 times negative 1, which is plus 1. Okay. So let's continue here. So we got this is my adjustment for the next. Let's continue. This is how far we had done in the previous video slide. Let's continue here. So now we will divide the next column by 1. So this is 1 here. We would divide in that column by 1. So we get a 1 here. Now we have to make an adjustment because of this deficiency here, transpose of surplus and this quotient digit. Okay, adjust for the transpose. So we got a 1 here, and 1 times 1 is minus 1, and we would divide the next column by 1. 2 minus 1 is 1. So we would get a 1 here as a quotient digit. Okay, now we have to do a adjustment. Adjust for the transpose. 1 is the quotient and transpose is negative 1. 1 times 1, negative 1 is minus 1. So that's my adjustment here. So we got adjustment here. So now we divide the next column. 9 minus 1 is 8. So we got 8 in the quotient digit here. 8 times minus 1 is the adjustment. That's minus 1 and for the next column here. Okay, let's continue. So in this column here, we have 1 minus 8 minus 7. We would divide that minus 7 by 1. Continue here. Okay, so we get a minus 7 as a quotient. Minus 7 times minus 1 of the transpose equals plus 7. So that's my adjustment for the next column. Let's continue. So we adjusted there. Okay, let's continue here. And total in the right hand column is 11. That's my remainder part of the division. Okay, let's continue here. Now we would resolve negative number. There's some negative numbers here. 1 here on second position and 7 here, 1 to the left of the remainder negative. Okay, let's continue here. So this is 1 and minus 1, which is in, if you take these two positions together, it's a 10 minus 1. Okay, let's continue. That's 0, 9. So we would have a 0, 9 here in these two positions here. Okay, and next these are positive, so they stay. Two digits stay as 1, 1. So we no problem there. Okay, next is 8 here and 7 negative. So that's like 80 positive and 7 negative. 80 minus 7 is 73. Okay, let's continue. So next position is 8, 7, which is 80 minus 7, which is 73. Okay, let's continue. So 7 here and 3 here. And then, so it is all improper fractions here in remainder, which is 11 is a, and we're dividing by 11. So it's 11 divided by 11 is a improper fraction. So we would, okay, that means that answer is 1002914 divided by 11 is 9. Okay, let's consider another example is 2850 divided by 11. So now my dividend is a lot smaller than the what we considered in the previous example. This is the way set up. 2850 divided by 11, which is base is still 10, surplus is still 1, and transpose is minus 1. Two steps are 10 times 1, first by 10 and next by 1. Let's continue here. So 2850 my dividend, 11 my divisor, and transpose of surplus is negative 1. Negative 1 here. Let's continue here. Divided by 10, that's our usual first thing we do, divided by first division. Okay, let's continue. So we just did. When we divide 2850 by 10, I have a 285 as a quotient and 0 as a remainder. Let's continue here. Now we would divide by second division, which is 1, first column. So 2 divided by 1 is a 1. Okay, 2 divided by 1 is 2. So we got 2 as a first quotient digit here. Okay, now adjustment for deficiency or transpose. It's a 2 times negative 1 minus 2 is adjustment for the next column. Let's continue. So we got minus 2 here. Next column is 8 minus 2, which is 6, and we divide by 1 to get a 6 here in the next quotient digit. Okay, so next quotient digit is divided by 1, so we get 6 here. Now we have to make adjustment for the deficiency or transpose here. 6 times minus 1 is a negative 6. Okay, let's continue here. We do adjustment and we get minus 6 here. In this column here, we got a 5 minus a 6. That's negative 1. Okay, we would divide that by 1, get a negative 1 here. Okay, let's continue here. Divide into the next column by 1. Okay, so we got negative 1 here. Now the adjustment, because that is negative 1 for transpose and negative 1 for the quotient digits. So adjustment is plus 1. Okay, let's continue. Adjust and got plus 1. Let's continue here. So we got a 1 as my total in the remainder column here. Let us continue. So that means that this is 260 26 bar 1. So this, if you look at these two digits here, 61, 6 positive and 1 negative, that's a 60 minus 1. So in the quotient I have a 260 minus 1, which is 259, and remainder is 1. So we got in it. When we divide 2850 by 11, I get in it. Take an example of division by 12, and we take example is dividend is 995,817 divided by 12. Base number is 10. Transpose is minus 2. See, I usually take a larger dividend numbers to see as if there are any issues involved here in division. And most of the time, you probably won't have to divide, have a dividends of no more than 4 digits. So let's continue here. Two-step division is 10 times 1, first by 10, then by 1. A setup problem is dividend 9955817 and divisor is 12. Transpose of the surplus is minus 2, which is bar 2. Let's continue. Okay, we are going to divide by 10. So we just did. So if I divide 995,817 by 10, I got it 99581 in the quotient and remainder is 7. Let's continue here. Divide the first digit by 1. So this is the first digit. We are going to divide that by 1. So I got a 9 here. Okay. Okay. Now the adjustment is 9 times minus 2 is minus 18, and that's the adjustment for this next column here. Okay. Adjust 9 times bar 2 is 18, negative 18. Okay. So we get negative 18 here. Now, in this column here, I have a 9 minus 18, which is minus 9. Let's continue here. We're going to divide. So we have a minus 9 in this column, next column here, as a quotient digit. Now, adjustment is 9 negative and all right. Let's continue with the division problem. Divide by 12. Okay. Here is how far we have got in the previous slide here. Transpose is minus 2, which is negative 2 here, and we have done first division, first column, and the adjustment for that. Then we had done adjustment division in the next column. Let's continue. Now we have to apply transpose, adjust for transpose with 2 times negative 9, negative 2 times negative 9 is plus 18, so plus 18 is the adjustment in the next column here. Okay, let's continue here. Now 5 plus 18 is 23. We have to divide in that column by 1. Okay, so 23 is my quotient value in this position here. Let's continue here. Now we are going to adjust for the transpose, which is 2 times 23, which is negative. Negative 2 times plus 23 is negative 46. We got that. Let's continue here. Now in this column I have a 8 is a positive and 46 is a negative. Let's continue. So that's negative 38 here. Okay, negative 38 here. Let's continue. Now we are going to adjust for the transpose 2 of in the transpose value negative 2, 38 negative in the quotient value. So adjustment is 76 for the next column. Let's continue. So we got 76 adjustment in the next column here. Now we are divided by 1 in this column here. 1 plus 76 is 77. So we got 77 in the quotient value here. Let's continue here. So we got 77 is the quotient value in this position. Okay, let's continue. Adjust for transpose. So we have 77 here. 77 is positive. 2 is a negative. Negative 2 times 77 is negative 154. So that's my adjustment in the remainder column. Let's continue here. So we have 146 negative, 147 negative in the remainder column. We have to resolve all the. Okay. So this is the setup so far. Okay. When we adjust 9 positive and 9 negative, which is if two digits together become 90 minus 9, which is 81. Let's continue here. We rewrite, so this 23 is 3 and a 2, 3 in this position and 2 get carried to the position on the left. Let's continue here. So here's 38, we have 8 negative in this position and 3 get carried to the position to the left. Let's continue here. So this 77 here, 7 stays in this position and the other 7 get carried to the left. Let's continue here. So quotient right now is 8, 3, 0 and a negative 1 here and a 7. Okay, so which is only one digit is negative here. So 301 negative is 300 minus 1, which is 299. So we have 82997 in the quotient. We still have a large negative value in the remainder 147. Let's continue here. So negative 147 is equal to negative 156 plus 9, and that is minus 13. Okay, let's continue here. So that is remainder is its quotient fractional value is negative 147 divided by 12, which is equal to negative 156 divided by 12 plus 9 divided by 12, which is equal to quotient is 13. 156 negative divided by 12 is negative 13 and plus 9. Remainder is 9. So if I take minus 17 off from 82997, that gives me the quotient value and remainder is 9. Let's continue. That means 995817 divided by 12 is 82984. 82984 I got from subtracting 13 from 82997. Okay. We ran into multiple digits positive values, multiple digits negative values. Even with bar numbers, we need to handle this carefully. Tirthaji used examples where quotient is either one digit or two digit. However, but this is the general method of division and we should be able to apply that to general cases. So I have tried to use larger dividends to expose the issues you might get in. Okay, let's continue. Yeah, you go ahead and try the example in Tirthaji's book and see that you'll find them a lot easier. Let's continue here. So I would look at one of the examples here, trying to compute 1 divided by 13 and decimalizing that. The digits and quotient values and also in the adjustment value bounces between 1 and negative 3, 9, 27, negative 81, etc. etc. Okay, let's continue here. We will use altered remainders to reduce the issue. We would mitigate this issue by using altered remainders. Okay, let's continue. We would what the altered remainders is. Let's do example 10972 divided by 32. Let us continue. Divisor is 32, base is 30, surplus is 2. Okay, 30 is a proportional base number and 2 is surplus of 32 from 30. Transpose is negative 2. Let us continue. Two-step division is 10 times 3. 30 is the base. First division is always by natural base number and second division is the other factor required to make up the base. The other factor is 3. For base, proportional base number of 30 and proportionality is 3. So we would divide first by 10 and then by 3. Let us continue here. Here's the example setup. This is my dividend 10972. This is my divisor 32. This is my natural base, proportional base I'm going to use for division, and 2 is negative 2 is my transpose. Okay, let's continue here. First we divide by 10. This is my first division. Okay, so we just did. Okay, let's continue here. Now we would divide this two digits 1 and 0 by the second division 3. Okay, so 10 divided by 3 is 3 remainder 1. Let's continue. So 3 is my quotient and 1 is my remainder, and now I've got to make adjustments for both for the quotient and also for the remainder. Let's continue here. Adjustments are remainder 1 is a proportional, and proportionality is first division, which is 10. 1 times 10 is 10 plus 3 times the transpose 2 negative is 2 negative times 3 is negative 6. 10 plus negative 6 is 4. So adjustment for the next column is 4. Okay, we've got 4 here. Let's continue. Now we would divide in the next column. 9 plus 4, we have to divide by 3, the second division, which is 4 remainder 1. Let us continue here. So we got 4 here in the quotient digit, remainder is 1. Okay. Now adjustments for 4 and remainder 1 go in the next column here. Okay, let's continue here. Remainder 1 is a proportional, so 1 times 10 is the adjustment for the remainder, and the quotient times the transpose is 4 times negative 2, which is a negative 8 here plus 10 here. So it's a 2, positive 2 is the adjustment in the next column. Okay, 2 here, 7 plus 2 is 9 we have now. Okay. 7 plus 2 is 9, and we are divided by 3, that gives me 3 remainder 0. Okay, we got 3 remainder 0. Okay, let's continue. So 7 plus 2 is 9. 9 divided by 3 is 3 remainder 0. Okay, continue. Okay, now next is adjust for the adjustment here. The remainder was 0, so only adjustment is 3 times the transpose. That's a negative 6. So in the if you add in the remainder column, I have a negative 4 here. Let's continue here. So that means I have a remainder 10 10972 divided by 32 is this is a negative 4. I have to borrow 1 from the quotient, so it becomes 32. This is a minus 4 divided by 32. Okay, so that means, and that becomes 342 remainder 28. Okay, let's continue. Okay, let's continue with altered remainders here. We have been mentioning altered remainders, and let us see what those are. Let's continue here. Altered remainders, from a division we can get different values of remainders. Okay, we call these different values as altered remainders. Okay, let's be patient and let's see what we are trying to talk about here. Okay, let's continue here. In getting altered remainders, we do not change the integrity of the problem. Instead, we replace the proper fraction in the remainder by improper fraction, such that in division we have this, we maintain the integrity. Dividend is equal to quotient times divisor plus remainder. Dividend and divisor are the in the domains of the problem, and quotient and remainder are the solution domain. So we altered the quotient value, we maintain the integrity of this problem here. Dividend equal quotient times divisor plus remainder. So we adjust the quotient and remainder so that the integrity stays. So we alter quotient value to achieve a suitable remainder. In conventional math, if we were to divide 936 by 19, a student might use a first quotient digit of 5. That would have given a first remainder of negative 2, which is, so 19 times 5 is 95. 95 subtracted from 93 is negative 2. Oops, that was an overshoot, and backtrack to quotient digit of 4, and then we got a 19 times 4 is 76. We would get a remainder from first two digits of 17. Okay, let's continue. That's, we just altered remainder to 17. We just did we would call that, instead of using a remainder of negative 2, you got an altered remainder of plus 17. We just use a alternate remainder of 17. Let's continue the discussion of altered remainders. Let's continue here. Example, We would use an example to illustrate the altered remainders. Okay, a teacher wishes to teach division to the students. A teacher and brings out 27 pencils from the supply cabinet. Let's continue. There are 7 students and 27 pencils. Objectives of the experiment is to find out if we were to distribute pencils equally to the students, how many pencils would each student get. Let's continue. Let's see how we do that. Okay. So at step 0, we have a 0 groups of 7 and 27 pencils remaining. So we are trying to do that, find out how many groups of 7 of pencils we can extract from the 27 pencils we have. Okay? Okay? So step 1, we subtract a group of 7 from the pencils, and we make a one group of 7. From one group of 7, we can distribute, there are 7 pencils in this group, 7 students. We can give out 1 pencil each equally to the 7 students. And after we extracted 7 from the pencils, we have a 20 remaining pencils. Okay. So at step 1, we get a one group of 7. If we were to distribute 1 pencil each to each student, I would have 20 pencils left. Let's continue here. So step 2, we subtract out another 7 pencils, make another group. We got 2 groups of 7. So from pencils so far extracted, we can give out 2 pencils to each of the students, and we would have 13 pencils still left. Okay. So step 3 is we would take out 7 more pencils from here and make another group of 7. So I have 3 groups and remaining pencils are 6. So 6 is less than 7. I won't be able to take out another group of 7 from here. Okay, so we have 3 groups of 7. So if we were to distribute 3 pencils each to each of students, then 6 would still be remaining pencils. Okay, so let's see where the altered remainders come in. In the above, 27, 20, and 13 are altered remainders. 6 is our usually nominal or typical remainder. If I use 6 as a typical remainder, that would give me a proper fraction of 6 divided by 7. If I use the other remainders, altered remainders, I would get a improper fractions in the remainder column. Okay, let's continue. Let's consider an example 11378 divided by 12, and we will try to see if we can use altered remainders in here. It's 11378 divided by 12. Okay, divisor is 12, base is 10, surplus is 2, and transpose of surplus is negative 2. Let's continue here. Two-step division is 10 times 1. 10 is our natural base number, and 1 is the other factor of the chosen base number. Chosen base number is 10, other factor is 1. So second division is by 1. Let's continue. The setup problem is 11378 is my dividend, and divisor is 1, 2, and transpose of surplus is negative 2. Let's continue here. Divided by 10. That's the first division we do, and we divide by 10. Okay. So this was first division here. We just divided by 10. Let's continue here. Now we go divide by second division. 1 in the first column. 1 divided by 1 is 1. The remainder 0. Okay, let's continue here. So 1 and remainder is 0. Adjustment is in next column is 1 times negative 2, which is a negative 2. Let's continue here. So we have adjustments of a negative 2 in the next column. Let's continue. Now in this column here I have 1 minus 2, which is a negative 1 here. Okay. So we would divide in the next column by 1. So we would get a negative 1. Let's continue. So we get negative 1 here now. Now adjustment, because that is negative 1 times negative 2 is a positive 2 in the next column. Yes, adjustment is for the transpose, which is that one, is negative 1 times negative 2. Negative 1 is the quotient, negative 2 is the transpose, positive 2, and that's adjustment for the next column. Okay, so we got in a 2 here. Okay. Okay, now we are going to divide the next column. 3 plus 2, 5 by 1. If I do 5 divided by 1, I get 5, remainder 0. But that would have given me a negative value in the next column. Okay, When there were negative value here, we let it stay. We want to see how we can use the altered remainders to change that to positive value here. So instead, we would get a 4 remainder 1. Use instead of 5 divided by 1, instead of doing a typical nominal 5 divided 5 remainder 0, we would do a 4 remainder 1. Let's continue here. So we get 4 here. Okay, and now the adjustments. Okay, one remainder is a proportional. Proportionality is 10 or first division. So adjustment because of 1 is 1 times 10, and that due to the transpose is negative 2 times 4, which is, so we got 1 times 10 plus this negative 8 here. 2 is the adjustment in the next column. Okay, so we get 2 here. Now in this next column here, we got 7 plus 2, which is 9. Okay, so we have a 9 here, and we would divide in the next column. Okay, let's go divide. 9 divided by 1 is 9 remainder 0, but that would make the next column a negative. Okay, so we will use 8 remainder 1 instead. Okay, let's continue. So we got 8 here, and 1 is the remainder. Okay, let's continue. Adjustments is 1 remainder is proportional, so 10 times 1 is the adjustment due to remainder, and 8 times the negative 2 is the adjustment due to the quotient and the transpose. Okay, so total quotient is 10, 10 adjustment is 10 and minus 16, which is a negative 6. Okay, let's continue here. So we got negative 6 here. Okay, okay, let's continue and add. If we add up the remainder column, we got a 2 here. Okay, 8 minus 6 is a 2. Okay? Now we have to resolve this negative 1 here. Okay, continue here. So if I resolve one positive and one negative, which is, if I take just these two digits, that 10 minus 1 is a 9. Okay, so it's got 9, 4, 8 in the quotient column and 2 in the remainder column. So 1, 1, 3, 7, 8 divided by 12 is 9, 4, 8, remainder 2. We use some altered remainders here and also in this column. Okay, that's good. Now we do another example here. 12261 divided by 72. Divisor is 72. Base number is 70, near 72. Surplus is 2. Transpose is 2 minus negative 2. And two-step division is 10 is our first natural base number is first division, and its other factor to make up the base is the second division. So 70 was my chosen base, and 7 is my proportionality of 70 from 10. Okay, so 7 is my second division. And here setup is 12261. 72 is my divisor and 2 is my transpose. Okay, let's continue. Divided by 10, that's the first thing we do. Divided by 10. Okay, let's continue. We just did. Okay, okay, now divided by 7, our second division is 7 here. So 12 divided by 7 is 1, the remainder 5. Let's continue here. Make 1 here. Remainder is 5. Let's make adjustments now. Adjustment due to 5 is 10 times 5, and 1 gives me 1 times negative 2. So 48 is the adjustment for the next column. Let's continue. So we get 48 here. So we have 2 plus 48, which is 50 in the next column. Let's continue. Now we would do it divide in the next column, which is given 50 divided by 7. We give 7, remainder 1. Okay, let's continue here with 7, and the remainder is 1. Quotient is 7, remainder is 1. Let's continue here. Adjustment in the next column is because of 1 here, which 10 times 1 is positive 10, and because 7 here, 7 times 2 negative is minus 14. So adjustment in the next column is 4. Let's continue. Negative, 4 negative. So next column we have 6 minus 4, which is 2. Let's continue. Now we will divide next column by 7. So 2 divided by 7 is 0, remainder 2. Let's continue here. 0. So we got 170 here, 0, remainder 2. Let's do the adjustments now. Adjustment is quotient is 0, so no adjustment for the transpose, but the remainder is 2. We have adjustment of 20. So in remainder column we have 21 after that. Okay, continue. So 21. Okay, so if I divide 12261 by 72, I get a 170, remainder is 21. Continue. Okay, so that means remainder, this is the problem. So 170, remainder 21. Let's continue. Okay, let's do some exercises now. Use the method we just did and compute this quotient and remainder in the following divisions. Okay, 13354 divided by 11, 12415 divided by 23, 15970 divided by 29, 21, 11827 divided by 11, 12348 divided by 32, 10404 divided by 23, and so on, and some more. Let's continue here. Divisor is 13. We would decimalize 1 over 13 instead of, if we were to say quotient is 0, remainder is 1, and that's straightforward, but we want to decimalize this thing. It's 13 is the divisor, base is 10, surplus is 3. Surplus of divisor 13 from 10 is 3, and transpose of that surplus is negative 3. So negative 3 of transpose. Okay, this is where we set up problem. Two steps are first divide by 10 and then by 1 and make the adjustments for this transpose. Dividend is 1 and quotient divisor is 13 and surplus is negative 3. Let's continue here. First we divide by 10, the usual divide by 10 we just did. That converts 1 into 0 0.1. Okay, let's continue here. So first we divide by 1 in first column we have and then adjust and divide. Let's continue. Because 0 0.1 adjustments is negative 3, 1 times negative 3, and next quotient, that would be my next quotient also. Okay, so we've got 3 negative. The next question is plus 9. Next is quotient value is negative 27. Let's continue. That means we'll continue through this number like 1, 3 negative, 9 positive, 27 negative, 81 positive, 243 negative, and so on and so forth. So every time we get in a position quotient value, next is that quotient value times negative 3. Okay, so we'll go through these numbers. So if you look at here, we have 5 digits of the quotient. This is the value that goes in the current quotient positions, and these 4 values get carried to the 4 positions to the left. Okay, that means that even though you computed the previous positions of quotient, the values, they keep the successive quotient values can affect the previously computed quotient value. So we'll go through 59049, 177147 negative. Okay, let's continue. Question: would we do something like that in Vedic math? We were trying to do a simplify as much as possible. It doesn't look like simplification here because so many carries, positive and negatives, 2-digit value in a quotient, 2 digits, 3 digits negative, 3 digits, 4 digits negative, and so on. Okay, no way. Look for an alternate. However, getting familiar and going through the exercise is educational. We will try to expose the issues involved in transpose and apply method of division. Okay, let's do to resolve them. So same thing, divisor equal 13, base is 10, surplus is 3, transpose is negative 3. Two steps, first divide by 10, then by 1, set up 1 as dividend, 13 as a divisor, and negative 3 is a transpose. Okay, first thing, as usual, we divide by 10. 10 is our first division. Okay, so we just then divide by 1. Okay, that means this 1 becomes 0 0.1 here. So we got a 1 here. 1 divided by 1 is 1, remainder 0. Okay, just for transpose, that's negative 3. Okay, so we just did. Okay, now divide in next column. So 3 negative divided by 1 is 3. Okay. Let's continue here. Next is adjust for transpose, and that's give me plus 9. Let's continue here. So if you divide 9 by 1, I get 9 divided by 1, and which is equal to 9 remainder 0. But if I use 9 remainder 0, next column is going to be negative 27. This one was negative 3, was one digit, we let it stay. Now if I keep use 9 remainder 0. Next adjustment will be negative 27. That's negative and 2 digits. We want to do something so that I don't get a negative adjustments in the next column. Let's continue. That would mean negative 27 in next column. Okay, and instead of using 9 divided by 1 is 9 remainder 0, we would use 9 divided by 1 is 6 remainder 3. Okay, that's my altered remainder. That's like backtracking in a conventional math when we are doing overshoot in a division. So we just we are getting negative values in the next column, so we just overshot the in division. We're going to backtrack, and instead of using 9 remainder 0, we would do 6 remainder 3. Okay, let's continue here. So we got 6 here. So far this is what we had done. We had 6 here. We use 9 divided by 1 is 6 remainder 3. Let's continue. We just did that. Now adjustments in the next column is 10 times 3. That's remain. This is a proportion plus 6 times the adjustment due to transpose. Okay, so that's 12. This is 12 here. So adjustment in next column is 12. Okay, let's continue here. So we could do 12 divided by 1 here in divided by 1, 12 remainder 0. Okay, and instead we will use 9 remainder 3. If we were to use 11 remainder 1 or 10 remainder 2, you would still have a negative adjustment. When I use 9 remainder 3, I will get a positive adjustments in the next column, which is 30 minus 27, which is plus 3. Let's continue here. Okay, now I get 9 here. Okay, now let's continue. So far we have done it. We just did a 9 remainder 3. 12 divided by 1 is 9 remainder 3. Okay. Adjustment is 10 times 3, that's a proportional remainder, and plus 9 times this adjustment due to transpose. So I get a plus 3 is adjustment in the next column. Let's continue. So now I divide 3 divided by 1. Okay, and I would use 2 remainder 1, same argument. I don't not want to make the next column negative. Let's continue here. So get 2 remainder 1. Okay. Adjustment in the next column is 1 remainder, which is a proportional 10 times 1, and quotient is 2, 2 times the negative 3. So next adjustment is 4. Okay, let's continue. 4. Okay, now I would use 4 divided by 1 is 3 remainder 1. So you see that I'm trying to avoid the situation where remainder is 0. Instead of 4 divided by 1 is 4 remainder 0, I'm getting 3 remainder using 3 remainder 1. Let's continue here. So I got 3 remainder 1. Adjustment. The next column is 10 times 1 plus 3 times negative 3, which is plus 1. Okay, so we got in same situation here. We started with 1, we got into 1 again, and it repeats. Okay, that means 1 over 13 is 0 point and 1 positive and 3 negative. These two digits work out to resolve to 0, 7. 10 minus 3. Okay, so 0, 7, 6, 9, 2, 3 recurring, and we start repeating because it's going to come back again. 1 divided by 1 is 0.1 again, and 3 negative 3, and so on and so forth. Okay, so we avoided some of the issues. I let one negative number stays here. Okay, other than that they're all positive and they repeat. Okay, continue. The same thing 1 over 13, but we'll do indirectly. First of all, the transpose apply method is indirect. Now I would add one more indirection here. Okay, so instead of doing 1 over 13, I will do 7 divided by 91. Let's continue. Divisor is 91, base is 90, surplus is 1, and transpose of surplus is negative 1. And setup is 7 in the dividend place, 91 in the divisor place, and the transpose is negative 1, and two steps are 10 times 9. So we are going to divide first by 10 and then by 9. Let's continue. Divided by 10, we just did. So here, let's continue here. So now I have 7 here, and we're going to divide that 7 by 9, and it is 0, remainder 7. Okay, so that's what you got, 0 dot, and this is the way I'm going to show that 0 and the remainder is 7. Okay. Now adjustments is 7 times 10 plus 0 times transpose, which is negative here. Okay, 1. So next adjustment is 70 and divide by 9. 70 divided by 9 is 7, remainder 7. Okay, let's continue here. So 7 is a part of the results, and this 7 here is my scratch pad number. Okay, let's continue. In next dividend is the 7 is proportional here. 7 times 70 plus the quotient times the transpose. So it's a 63. 63 divided by 9 is 7 remainder 0, but that would get me a next digit of quotient digit of value of negative. So I'll just use a backtrack there and use 6 remainder 9. 63 divided by 9 is 6 remainder 9. Let's continue here. So I got 6 remainder 9. Next dividend is 9 times 10 plus 6 times negative 1. So 84. I divided by 9. 84 divided by 9 is 9 remainder 3. Let's continue here. This is how I show it. 9 remainder 3. This 9 is a part of the answer, and this 3, which is remainder, is my scratch pad number. Let's continue. Next dividend is 3 times 10 plus 9 times 1, negative 1, which is 21. 21 divided by 9 is 2 remainder 3. Let's continue. 2 remainder 3. Let's continue here. Okay, next dividend is 3 times 10 plus 2 times 1. 28. 28 is divided by 9 is 3 remainder 1. Okay? 3 remainder 1. Let's continue here. Next dividend is 1 times 10. 1 times the remainder, which is proportional, plus 3 times negative 1, which is 7, which started with 7, come with 7, repeat. So that means 1 over 13 is 0.076923 recurring. Let's continue here. Sizes. 1 over 7 is 0.142857 recurring. Okay, continue. You compute 1 over 7 from 3 divided by 21. Okay, let's continue here. 1 over 17 is 0.05882352 94117647 recurring. These are 16 digits here. There are 6 digits here recurring and there are 16 here recurring. Okay, let's continue here. Compute that 1 over 17 from 3 divided by 51. Compute at least up to 6 places. That means compute first 6 1 up to 3 here. Okay, let's continue. Okay, let's consider an example of 674957 divided by 112. Now I'm considering a 3-digit divisors. Let's continue here. So divisor is 112, natural base number is 100, which is natural base number. Surplus is 12. 112 has a surplus of 12 from base number 100. And transpose of the surplus is negative 12. Let's continue. A two-step division is 100 is the base number we have chosen. Its natural base number is 100 and the other factor is 1. So we first divide by 100, then we divide by 1 and make any adjustments we need to make. Let's continue. This is the best side of the problem here. Dividend is 674957. Divisor is 112 and transpose of surplus is negative 12. Let's continue. First we divide by 100. This is my first division here. Okay, we just did. Then we divide this column 6 by 1. 6 divided by 1 is 6, remainder 0. So we got 6. This is we write down 6, remainder 0. Okay, now adjustments. Adjust for next two columns is 6 times negative 12 is negative 72. Okay, let's continue. Okay, negative 72. Let's continue. Okay, dividing next column is 7 minus 7 is 0. We divided by 1. That's my next second division. 0 divided by 1 is 0, remainder zeros. Okay, so we just did there, 0 remainder 0. Okay, Adjustments are 0 times 100. This is for the remainder. And this is 0 times 12. This is for the quotient. Negative 12, which is 0. Okay, so we got two adjustments of 0, 0 in the next two columns. So far we have achieved, gone so far here where the quotient was 0 and adjustments was 0 and 0 in two columns. Let's continue. Now we have 4 minus 2 in this column, which is 2. 2 divided by 1, the second division, is a 2 remainder 0. Okay, let's continue. So we just say 2 remainder 0. Okay, this 0 is not part of the answer. It's my scratch pad number. Okay, 6 is a part of the answer. This 0 is part of the answer. This 2 is, and the one remainder digits we put in on side, they are not part of the answer. They are my scratch pad numbers. Okay, let's continue here. Adjustment in next two columns is 0 times 100, 0 from the remainder, and 2 times negative 12, 2 is from quotient. Okay, this 2, okay. Negative 12 is the transpose. Okay, so it is negative 24. Okay, and this is where we represent negative 2 and a negative 4. Okay, let's continue here. In next column we have a 9 minus 2, which is 7, and we have to divide by 1, my second division. 7 divided by 1 is 7, remainder 0. Got that. Adjustments are for 7. Remainder 0 does not contribute anything to adjustments, but the quotient does. Quotient 7 times the transpose. That's negative 84, and we use that in two columns, 8 and 4. Okay. Let's So we have achieved so far in the previous slide. Let's continue here. Quotient is 6027. Okay. A remainder is 50 minus 40 minus 80 plus 7 minus 4, which is minus 67, which is minus 112 plus 45. Minus 112 contributes 1 to the quotient side. Let's continue here. That means that contribute negative 1. So it becomes 674957 divided by 112 is 6026, remainder 45. Let's example. We will take example where we divide by 311, which is 3 digits, but it's a proportional base now. Example is 133009 divided by 311. Let's continue here. Divisor is 311 right here. Base is 300. Surplus is 11. Surplus of divisor 311 from a chosen base of 300 is 11, and transpose of this surplus is negative 11. Let's continue. Two-step division is 100 times 3. 300 is chosen base, 100 is the natural base, and 3 is the other factor. Okay. We would first divide by 100, then by 3, and make any adjustments. Let's continue here. Set the problem like this. This is my dividend, that's my divisor, this is my surplus. So dividend is 133009, divisor is 311, and here is transpose of the surplus is negative 11. Let's continue. First we will divide by 100. That's my first division here. We just did. Okay. Continue here. Then we divide this 13 by 3, second division, which gets me 4 remainder 1. So we get 4 remainder 1. Now the adjustments for next two columns is 1 remainder times 100. 1 is remainder is proportional. Proportionality is 100. First division. And this is a 4 quotient. Adjustment due to quotient digit of 4 is 4 times negative 11. So that's giving 56, and that's for the next two columns. So we got 5 and a 6. Let's continue. It's a 133009 divided by 311. Let's continue. We have achieved so far in the previous slide. Let's continue here. So next now here 3 plus 5 is 8. 8 divided by 3, our second division gives me 2, remainder 2. Let's continue. Okay, now adjustments here. For the remainder 2, 2 times 100, 100 is my proportionality here. And for the quotient 2, it is 2 times negative 11. So it's 178 for the next two columns. Okay, so this how looks like 178. Okay, okay, and divide the next column. 6 plus 17 is 23. We have to divide by 3, our second division. 23 divided by 3 is 7, remainder 2. Let's continue here. So that's how I say 7 and remainder 2. 7 and a 2 and a 4 are part of the answers. There's 1, 2 and 2. The remainder digits are not part of the answer. These are my scratch pad numbers. I'm writing them down for record keeping purposes. Okay, let's continue here. Now adjustment for next two columns is for remainder is 2 times 100. 100 is proportionality. This 2 is proportional remainder. And for 7 quotient, 7 times the transpose, which is 7 times negative 11, which and it's 123 for the next two digits. Okay, let's continue here. That's 12 here and 3 here, 123. Let's continue. Total in the remainder column is 212. Okay, 80 plus 120 is 200. 200 plus 9, 209 plus 3, 212. Let's continue. That means that if I divide 133009 divided by 311, I get a 427, remainder 12. 427, remainder 212. Example 152996 divided by 1103. Now I have a 4-digit divisor. Divisor is 1103, base is 1000, surplus is 103, transpose of the surplus is negative 103. Let's continue. Two steps division is 1000 times 1. 1000 is natural base number and 1 is the other factor of the chosen base. Okay, let's continue here. Set of the problem is the same way. Dividend, divisor and a transpose. Dividend is 152996. Divisor is 1103 and transpose is negative 103. Let's continue here. First we divide by 1000, our first division. Okay, so we just did. Let's continue. Divide in first column, which is 1 divided by 1 is 1, remainder 0. Okay, so we got 1, remainder 0. Adjustments are 1 times the transpose 103, and that's in for next three columns. So we got in 103. Let's continue. Divide in next column, I have 4. 5 minus 1 is 4. 4 divided by 1 is 4, remainder 0. Okay, so they got 4 here. Okay. Now adjustments are 4, 0, 1, 2. Okay, the first column is 4, next is 0, next is 12. Let's continue. Okay. Continue and divide in next column. 2 minus 4 is minus 2. Minus 2 divided by 1 is negative 2, remainder 0. Let's continue here. So we got negative 2 here, remainder 0. Adjustments for negative 2 would be 2, 0, 6. Let's continue. That's 2, 0 and 6 and that's 2, 0, 6. Quotient is 140 minus 2, 138. Remainder is 800 minus 30 plus 12 is 782. Okay, remainder is 782. Okay, let's continue. 900 plus 12, 1100 minus 300 is 800, and here is 30 here. So this is 90 minus 120 is minus 30, and 6 plus 6 is 12. That's 782. That means 152996 divided by 1103 is 138, remainder 782. Let's take another example of a 4-digit divisor. It's 802064 divided by 6112. Let's continue here. Divisor is 6112, base is 6000, surplus is 112. 6112 has surplus of 112 from base number 6000, and transpose of surplus is negative 112. Let's continue here. As two steps are 1006, we would first divide by 1000, then by 6 and make adjustments. Let's continue here. So set up problems like that. This is my dividend, that's my divisor, this is my transpose of surplus. Dividend is 802064, divisor is 6112, transpose is negative 112, and my second division is 6. First division is by 1000. Let's continue. So we divide by 1000 first, that's my first division, that's what we do first. Continue, we just did. Okay, now we divide by first and six, first column we divide by 6. 8 divided, this is 8 here, 8 divided by 6 is 1, remainder 2. Okay, so 1 and remainder 2. Now the adjustments. For remainder 2 is a 2 times 1000, 1000 is proportionality, our first division. And for the quotient 1 times the transpose, which is negative 112. So we have total adjustment is 1888. They are going next 3 columns. So this 8 goes in this column, this 8 goes in this column, and 18 rest of that goes in this column. Let's continue here. Let's continue. So now in this column we have to divide 18, divide 0 plus 18 is 18. 18 divided by 6 is 3, remainder 0. Let's continue. So we got 3, remainder 0, 3. Adjustments are remainder 0, so no adjustments for that, and 3 is the quotient. 3 times 112 negative is negative 336, and that's for next 3 columns. Okay, there are 3 zeros in the base numbers we have. Okay, let's continue. So I got negative 3, negative 3, and a 6. Let's continue. Divide in next column, which is 7 divided by 6, and that's 2 plus 8 is 10, minus 3 is 7. That gives me 1, remainder 1. Let's continue. Okay. Now, there are 2 adjustments. One for the remainder 1, which is 1 times the proportionality 1000. And for the quotient, it's 1 quotient times the transpose. Okay. So I have a total adjustment is 888 for the next 3 columns. Okay. There is adjustments here. Let's continue. Remainder is 800 minus 300 plus 800 plus 60 minus 60 plus 80 plus 4 plus 8, which is equal to 1392. 800 minus 300 is 500 plus 800, 1300. 1300, 60, 60 goes away, so 1300 plus 80, 1380 plus 84, 1384 plus 8, 1392. Okay. Alright, so when I divide 802064 by 6112, I get a 131, 131 remainder 1392, remainder 1392. Let's exercises now. Try the following. 12645 divided by 112, 12675 divided by 115, 10971 divided by 102, 10091 divided by 100, 10225 divided by 103, and some more. Now we are doing 4 digits. Okay, I continue. This method gives you alternate way to divide here. Okay, if you stay with natural base numbers, there's no division. Okay, we just got in add subtractions only. Continue here. The video uses the concept of two-step division and proportional base numbers in addition to natural base numbers. So in this video we do use both the natural base numbers and proportional base numbers. Let's continue here. Is it easy? It usually is. Okay. Introduce concept of alternate remainders, and that did mitigate some issues with the large negative numbers. Okay. Here is my usual reference is my teacher's manual, and this is the link to work few days ago. And Tirsaji is the book, my primary reference for the chapter, and Glover's books have exposure to this method, and I don't recall if Vanna's book has exposure to this method. Okay, that's all. Thanks.